Hello, now we are talking about the representation of data. So integers can be stored in different ways. And this depends on whether they are treated as unsigned or signed integers. So we have unsigned integers. We have also signed integers. Unsigned integers only represent they represent non-negative numbers. That is the 0 and the positive numbers. So for example, an 8-bit unsigned integer has a range of 0 to 255. يعني هون الانسايند بيتعاملوا بس مع البوزيتيف نمبرز، ما بيتعاملوا مع النيجاتيف نمبرز. بس نحكي عن الانسايند انتيجرز. إذا حكينا عن 8-bit unsigned integers، طبعا 8-bit يعني الماكسيموم فاليو يلي ممكن نوصل له هو 256 2 power 8. So in base 2 power 8 is 256. يعني we are talking about the values between 0 and 255. Unsigned integers represents non-negative numbers، يعني the numbers between 0 and 255, the 0 and the positive numbers. So the smallest value is 0, the largest value is 255 in binary. The range this is the range for an 8-bit unsigned integer. However, for the signed integers, an 8-bit signed integer can represent values between -128 to 127. So here the signed integers can represent both positive and negative numbers, as well as the number 0. This is the difference between signed and unsigned integers. So in an 8-bit signed integer, the most significant bit is used to represent the sign. We will see this in the next slides. So we have 8-bit, the most significant bit, يعني the bit at the left. This represents, this could be a sign for a positive number or for a negative number. يعني if the most significant bit is 0, this is a sign for positive numbers. If the most significant bit is 1, this is a sign for negative numbers. Of course, the remaining 7 bits are used to represent the magnitude of the number. And as you see, both signed and unsigned integers represent 256 distinct numbers. However, in the unsigned case, all values are non-negative, while in the signed case, the numbers are split between positive and negative values. Of course, with 1 bit reserved for the sign. In computer system, when we talk about the computer, any computer system, in any computer system we have memory. We have a memory locations store binary patterns. So this is important. In any computer system, memory locations store binary patterns. When I say binary patterns, this is a sequence of zeros and ones. If we want to store, for example, number 20 ما فينا نحن نحفظ النمبر 20 بالميموري of a computer بهيدا الشكل، يعني in decimal form. We need to convert it to binary لحتى نقدر نحفظها بالميموري. To binary يعني number 20 لازم تكون عبارة عن zeros and ones. However, these binary patterns by themselves do not have any meaning. It's up to the programmer to decide how to interpret or represent these patterns. طبعا حسب البروجرامر بأي لغة بده يشتغل، بأي لغة بده يحكي. مثلا 8-bit binary pattern يعني zeros and ones like this 10000010. So we have here 8-bit binary pattern. This can be interpreted as a non-unsigned integer. يعني هلا إذا حولنا هيدا الرقم لديسيمال هيطلع معنا 65. يعني 65 is stored in the memory of a computer in this form. أو نحن فينا نحفظها بشكل تاني، يعني فينا نستعمل what's called the ASCII character A. So هيدا number represents for example the character A in ASCII code. أو يعني we can use any secret information known only by the programmer. يعني البروجرامر المبرمج have to decide how to represent a data, a piece of data. Now the interpretation of the data of the binary pattern, this is called the data representation or encoding. This is called encoding or data representation. So in summary, I can say that data representation is essential, is important for a programmer. Any programmer should understand this, should understand the meaning of data representation and how to deal with data, how to interpret data, how to save data, in which way, in which code. So it is essential that the representation schemes are consistent and agreed upon by all involved parties, including the software, hardware, the developer. This consistency ensures that a given binary pattern is interpreted the same way across different platforms, across different devices, across different systems. So it is important that this data is agreed or are agreed upon by all parties, by industrial standards, by any other standards, or by any other parties. So what is an unsigned integer? Again, so it can represent 0 and positive integers, but not negative integers. So no negative numbers. Yani when we talk about unsigned integers here, we deal only with 0 and positive integers, no negative numbers. And this all numbers, so the value of an unsigned integer is determined value of the integer is interpreted or determined by the magnitude of its binary pattern. Let's look at the given example here. So here we have a binary pattern 10000010. Here B stands for binary. And when I say 10000010, and here we have the letter B. B يعني binary. So this is a binary pattern. So here n equal 8, number of bits here. We have 8 bits, so n equal 8. Suppose that n equal 8 and the binary pattern is 10000010. The value of this unsigned integer, as we discussed before, is calculated in this way, as you see here. So each position represents a power of 2, starting from 0 on the right. يعني هيدا الواحد اللي هون, this one, this position, here we can write 2 power 0. The second bit 2 power 1, 2 power 2, and so on. So for an unsigned integer, you add up the values of the positions where there is a 1. So here we have a 1 and here we have a 1. We add 1 times 2 power 0 and 1 times 2 power 6. We get 65 in decimal. So D here stands for decimal. It means decimal notation. B means binary notation.